Okay, so in section B4, we're going to be discussing factoring polynomials. When we factor, that just means that we need to write it as multiplication. It's also important that we look at the number of terms that a given polynomial has. So, for example, if you've got a polynomial that looks like, let's say, x squared minus 3x plus 6, this has 3 terms because we have 3 pieces that are separated by plus or minus. Another example might be x squared minus 4. We would call this a binomial. It's got 2 separate terms separated by a minus. And by the way, this one up here with the 3 terms, we call that a trinomial. If you've got just a single term and no plus or minus anywhere, so like let's say you've got 5x to the 5th power, that's a monomial. Okay, so it's going to be very important to look at the number of terms that we have to help us distinguish what's the appropriate technique to take for any given polynomial that we're needing to factor. Okay, so we have the definition for greatest common factor. Our definition states that the greatest common factor, or the GCF, is a monomial that includes every number or variable that is a factor of all terms of the polynomial. Let's look at an example to help illustrate what that's really saying. So for example 1, we're going to factor out the greatest common factor from each polynomial. So for example 1, we're asked to factor out the greatest common factor. We're given a trinomial because this has 3 terms. 9x to the 4th minus 6x to the 3rd plus 12x squared. In order to find our greatest common factor, we're looking for something that is common to all 3 of our terms. So let's start by looking at our coefficients. We've got a 9, a negative 6, and a 12. All 3 of those numbers are divisible by 3. If we look at the variables, we've got x to the 4th, x to the 3rd, and x to the 2nd. So the greatest common factor of those variables would be x squared. So we have a GCF of 3x squared. When we factor the 3x squared out, we're really dividing each of these terms by 3x squared. So 9x to the 4th, we take the 3x squared out. That leaves us with 3x squared minus 2x plus 4. Part B, we're going to factor out the GCF for x squared times y plus 10xy plus 25y. All 3 of these terms, and by the way, this will be a trinomial, it's got 3 terms. Each term has a common factor of, do you see what the common factor is? The common factor for each of these 3 terms would be the y. So we can pull out the y to the front. If we divide each term by our common factor, we're left with x squared plus 10x plus 25. Okay? Later we'll talk about how to handle the trinomials, but for right now we're just pulling out the GCF. So we use the grouping method to help us factor polynomials that have 4 terms. A polynomial with 4 terms does not have a special name like the trinomial or the binomial. We just call it a polynomial with 4 terms. In order to use the grouping method, it's similar to finding a GCF. You know, when you do a GCF, you're looking for a common factor to each term. With the grouping method, we're just going to concentrate on the first 2 terms. So just looking at the first 2, notice I'm not putting parentheses here. Do not put parentheses because it's going to look like you've already factored it. So I'm just going to put these little curly lines underneath. Looking at the first 2 terms, what do those 2 terms share? Well, they have a x squared in common. So we can factor x squared out as if it's the GCF of just the first 2 terms. That leaves me with x plus 1. Now let's do the same for the last set of terms down here. So these have a common factor of 3. Because this is addition, I'm going to say plus. I'm going to pull this 3 out. And then if I factor the 3 out of these 2 terms, I'm left with x plus 1. So we're kind of halfway there at this point. We started out with 4 terms, and because this is partially factored, we've now got, we can think of this as one big term, and this is one big term. Looking at these 2 big pieces that are separated by plus, do they have a common factor? Sometimes it's not so obvious to see at first glance, but remember, factors are things that are being multiplied together. So over here you're doing x squared times this entire x plus 1. So x plus 1 is a factor. Over here you're doing 3 times this whole x plus 1. So x plus 1 is a factor there. So you'll see that these two terms share a common factor of x plus 1. So just like with any common factor, we can factor that x plus 1 out. Factoring out x plus 1 leaves me with x squared plus 3. And then at this point, it's important to look at what we have and decide if this can be factored any further. The answer in this case is no. It does not factor any further. We'll talk more as we go along about how to determine if you can factor it further. So before we move on to part B of example 2, let's take a moment to discuss what it means to factor a negative number out of something. For example, let's say I've got x minus y, and then I have another factor up here as y minus x, and I'm wanting them to be the same factor, but they're not quite. We can turn this into a factor of x minus y if we just factor a negative 1 out. So just like you factor out any GCF, you can always factor out a negative 1. So if I factor a negative 1 out of this, it's just going to change the sign. That becomes negative y, and that would become positive x. So this becomes negative 1, and then you can change the order around, so it becomes x minus y. All right, so you'll notice that the signs here are now switched around, just have the negative in the front. So we can use this technique to help us with part B of example 2. Okay, so now we've got another 4-term polynomial that we're ready to factor. We're going to use the grouping method again. So looking at the first 2 terms, we'll notice that there is no common factor that we can remove this time. All right, so if this happens, you can try rearranging the terms. Let's take the middle 2 terms, flip them around the other way and see what happens. So AW minus BW plus BC minus AC. Okay, now if I look at my first 2 terms, I'll see I've got a common factor of W. So go ahead and remove W. That leaves me with A minus B. Over here, I've got a common factor of C. So with this being positive, I'm going to bring down my plus, and I'm going to factor out C. That leaves B minus A. Okay, so we're needing these factors to be identical, but unfortunately they're not this time. However, they can be made to become identical. All we need to do is factor negative 1 out of one of these factors. A minus B is nice. It's in alphabetical order. Let's leave it like it is. B minus A, let's factor negative 1 out there. So when we do that, it's going to become, we're going to factor negative 1 out, so it's going to be minus, because it's going to become plus negative 1 times C. So we'll have minus C, parentheses, and then if you factor negative 1 out of here, it's going to become positive A, negative B. Okay. If you need to see an extra step, you can think of this as plus, and we factored out that negative 1. So negative 1 times C, and then it left us with the A minus B inside. So now we have a common factor of A minus B. We can remove it, bring it to the front. We're left with W minus C. And we've factored our 4-term trinomial using the grouping method. So the grouping method is going to be very useful to us in some of the problems coming up. Okay, so let's talk about how we can use the grouping method to help us factor trinomials. Trinomials are something that I know you've had lots of practice with in the past, and you may be really good at it, but a lot of times people need extra help with it. So I'm going to show you how we can use the grouping method to factor a trinomial. What we can do is, we know that we need to have 4 terms when we go to factor when we use the grouping method. We can only use that. We use the grouping method if a polynomial has 4 terms. So let's find a way that we can write this with 4 terms. In order to do that, We want to find a pair of numbers that will multiply to give us negative 14, but they need to add to give us the negative 5 that we see in the middle. So if we think about factors of 14, okay, let's just think about the 14 and then we'll decide how to handle the signs. Well, you can do 1 times 14, or we could do 2 times 7. There are not any other choices when we're factoring 14. So that makes it kind of easy for us. Which pair of factors can we use to add or subtract in order to get a negative 5 here in the middle? We're going to have to go with the 2 and the 7. In order to get that negative 5, we need to first notice this sign. We know that this sign tells us that they have to be opposite signs. So because when you multiply two numbers together and you get this negative 14 here, they've got to be opposite signs to give you a negative value. So with that in mind, which one should be positive and which one should be negative? Well, if you're going to add them together and get a negative 5, that means that the larger one should be negative. So you need to have a negative 7 and a positive 2. I can use these two numbers to now rewrite my trinomial with 4 terms. So I'll have x squared, and in place of negative 5x, I'm going to write plus 2x minus 7x minus 14. Okay, so it's still the same. If you combine them together, you still got the same thing you had up here. Now factoring by grouping, looking at the first 2 terms, we can pull out x. That leaves me with x plus 2. And then over here, I've got a common factor of negative 7. This is a negative and this is a minus sign, so we're going to factor out negative 7. Or if you want to say plus negative, that's okay. And that leaves you with x. Because you're factoring a negative out, that's going to change signs and become plus 2. And fortunately, these are matching up. Now, if you get to this step and these two sets of parentheses are not the same, then this is not going to work. You'd have to go back and try again or try another method. But with these being the same exact binomials, x plus 2, we have a common factor. We can pull it to the front. So we're going to factor out x plus 2, and that leaves me with x minus 7. And that is factored. Okay, so now it's time for you to try one. See if you can factor x squared plus 4x minus 21. You may be wondering if you have to do the grouping method for this problem. No, you don't. A lot of you have probably done trial and error method when you're factoring trinomials, and that's fine too. Just see if you can factor this, pause the video, and we will check your answer in a moment. Okay, so let's see how you did. All right, so I'm going to do the I'm going to do the grouping method like we discussed earlier. Looking at my negative 21, how could I factor 21? I can do 1 times 21, I can do 3 times 7, and that's it. So if I use my 3 and my 7, I should be able to get a 4. Again, I need to have opposite signs to get my negative 21 here, and to get a positive 4, I need to have my 7 negative and my 3 positive. Hi guys, sorry about that. I just caught a mistake. That should be a positive 7 and a negative 3. So it should say x squared minus 3x plus 7x minus 21. And then when we factor, we're going to factor out a common factor of x parentheses x minus 3. And we'll have x minus 3 in the second set of parentheses. That minus 7 should be a plus 7. So when we're finished, our answer should be x minus 3 times x plus 7. So that should be x minus 3 times x plus 7. Okay, back to the video. Okay, so in your notes, you're probably noticing that there's a bit of a discussion about how to use the A times C method for factoring a trinomial. That's basically the same thing that we've just been doing, except now we have a coefficient. The A is the coefficient on the x squared term, or the leading coefficient. So right here in my first example, or in example 4, part A would be 2, B would be 5, C would be this 2. So to use the A times C method, I'm going to do the same steps that I did before, except that I have to multiply this number with this number to give me 4. So 2 times 2 is 4. And then I look at the possible factors of 4 that I can add or subtract to give me my middle term, 5. So I could do 1 times 4, or I can do 2 times 2. Those are my only choices. To get a positive 5, I want to go with the 1 and the 4. And this time, I've got a plus. Everything is positive, so this is a little easier. So I'm going to rewrite, it's a little easier than the last examples were, I guess. Let's use those two numbers to rewrite this with 4 terms. So we'll have 2x squared plus 1x plus 4x plus 2. Now looking at the first 2 terms, we have a common factor of x. We can pull that out. That leaves me with 2x plus 1. Looking at my last 2 terms, I'll bring that plus down, and I've got a common factor here of 2, and that leaves 2x plus 1. Okay? Do my 2 binomials match? All right, 2x plus 1, 2x plus 1, yes, those match, so we're good. You can pull the 2x plus 1 out to the front. Again, what if these are not the same? If these 2 binomials are not the same, then you need to go back and try it again. You probably messed up somewhere, or maybe it's not going to factor. But at any rate, we have to get the same factors here and here. So we can factor out the 2x plus 1 as our GCF. That leaves me with x plus 2. Okay, and that is my answer. I have factored the trinomial using the A times C method. Okay, so we're getting ready to start talking about how to factor special products. That includes perfect cubes, perfect squares. Before we jump into those problems, let's just quickly review what are the perfect squares and what are the perfect cubes. We talked in the last section about perfect squares, so let's just refresh your memory. Perfect squares would include 1, 4, 9, 16, 25, 36, 49, 81, 100, 121, and 144. That's probably as high as you would see on a test. However, you might have some higher perfect squares to appear in your homework. Right while I've got it on my mind, when you're doing the homework in my math lab, it's fine if you want to click similar exercise and get a new problem with different numbers. I don't have a problem with that. So you might decide to do that. Sometimes these numbers, when you're doing perfect squares and perfect cubes, sometimes those numbers can get really, really big. So if you need to use a similar exercise problem in your homework, that's okay. But at any rate, you need to be able to recognize all of these numbers as perfect squares whenever you see them in a factoring problem. The perfect cubes that you need to be able to recognize would be the following. So we know that 1 to the 3rd power is 1, 2 to the 3rd power is 8. The next one would be 27, 64, 125, 216, 6 to the 3rd. All right. 343, I think, is 7 to the 3rd, and 1,000 is 10 to the 3rd. I will not ask you any number that is not included on this list. I will not expect you to immediately recognize any number that is not on this list as a perfect cube. Again, it may come up in the homework, but if it does, you can, just kind of try to do it, or you can do a similar exercise if you need to. So these are the perfect squares, the perfect cubes that we need to be able to recognize as we begin to work with factoring methods for special products. So in your notes, there is discussion about the difference of squares, sum of squares, the perfect square trinomials. Read through that. Make sure that you know that if you see a sum of 2 perfect squares, for example, if you see x squared plus 4, this is a prime polynomial or a prime binomial, this does not factor. You could play with this thing and try to get it to factor as much as you want to, and I might let you do that in class as practice. But if you play with this thing, try to put numbers in that if you were to FOIL it back out, would give you this. As you play with this, you'll find that you can't do it. So the sum of squares is prime. The difference of squares, so what if we just change this to a subtraction instead of to an addition? So instead of x squared plus 4, what if you're doing x squared minus 4? Okay, you need to be able to recognize x squared is a perfect square, 4 is a perfect square. So we're going to apply the difference of squares formula. A squared minus b squared equals a plus b times a minus b. The a and the b are whatever values that you need to square in order to give you these two terms. So in order to get x squared in your first term, your a would be x. B would be, what would you square to give you a 4? It would be 2. You don't have to worry about a negative here. So putting these values into the difference of squares formula is going to give you x plus 2 times x minus 2. And once you apply your formula, unless you forgot to remove a GCF at the very beginning, once you apply that formula, you're done. Okay. In example 5, we are asked to factor using the special products. In part A, we've got 4x squared minus 1. When you approach this problem, again, you need to make sure that you can identify those perfect squares. You need to immediately recognize that this is a perfect square, 4x squared, and 1 is a perfect square. If you can do that, then you can factor it. All you need is the difference of squares formula, which we talked about a moment ago. You need to determine what your a and your b are. So a in your formula is whatever you're squaring to give you your first term. So a is 2x. B is whatever value you need to square to give you the 1, so that would be 1. Apply your formula, a plus b times a minus b, and you have 2x plus 1 times 2x minus 1. All right. And again, unless you forgot to remove a GCF in the very beginning, once you apply your formula, you're done. So for part B, you may recognize this as a perfect square trinomial, and you can use the formula that's given in the notes. However, it's not. You can also factor it as you would any trinomial. But let's do the grouping method like we discussed before. In order to do the grouping method, you're going to want to first of all, your first term, the coefficient is a 1. So if you're thinking of A times C method, it's 1 times 9. So you need factors of 9 that you can add or subtract to give you a negative 6. So you could do 1 times 9 or 3 times 3. Okay, we're going to need to do the 3 times 3. All right, and then we need to add these together to give us a negative 6. So they need to both be negative. So we've got x squared minus 3x plus 9. Keep in mind that because this is a perfect square trinomial, when we get finished, the two binomials need to be identical at the very end of the problem. So let's see what happens. Looking at the first two terms, I can factor out a common factor of x. That leaves x minus 3. And then looking at the last two, I've got a common factor of negative 3. So we'll factor out negative 3. And again, if this part confuses you, you can think of this. All you're doing is you're saying plus negative 3, and then what is left if you factor a negative 3 out? It's going to become positive x minus 9. I'm sorry, minus 3. Okay. Now we have a common factor of x minus 3. So this x minus 3 inside parentheses we're going to pull to the front as our common factor. And we're also left with another x minus 3. All right, and that's how we know that that's what we mean by perfect square trinomial. We should be getting the same factor multiplied by itself. That's what makes the perfect square. So you can write this as quantity x minus 3, or excuse me, you can write this as x minus 3 quantity squared for your answer. Okay, so in example 6, we're asked to, it just says factor the polynomial. They don't really tell us what method to use here. In part A, notice that you've got an x cubed, and 27, hopefully you recognize from that list that I gave you earlier as 27 is a perfect cube. 27 is 3 times 3 times 3. So if you recognize these as perfect cubes, then that is your indication that you need to use the difference of cubes formula. Why the difference of cubes? Because they're being subtracted. So A, for your formula, is going to, what do you cube to give you your first term? A is x. What do you cube to give you your last term? B needs to be 3. All right, and my formula, again, it's in your notes. Difference of cubes formula states that a cubed minus b cubed equals a minus b, parentheses, times parentheses a squared plus ab plus b squared. So using the formula, we're going to have x minus 3 in parentheses times x squared plus a times b is 3x plus b squared, which is 9. Okay. Again, the nice thing about these formulas is that unless you have forgotten to remove a GCF at the very beginning of the problem, once you applied your formula, you are finished. You do not have to go another step. So this is our answer. Okay, let's look at part B. We're going to factor 8w to the 6th plus 125z to the 3rd. How in the world are we going to go about factoring this thing? Well, hopefully you recognize your 8 and your 125 as perfect cubes from the list that I gave you earlier. Also, these exponents, since they're divisible by 3, they're also perfect cubes. So these are being added, so we have a sum of cubes. Always make sure that you get any GCF. Is there anything that we could take out of these two terms? There is no common factor between either the variables or the coefficients. So we're just going to jump into the formula. We're doing the sum of cubes formula. As a cubed plus b cubed equals a plus b in parentheses times parentheses a squared minus ab plus b squared. So we're going to do our a. What does our a need to be so that if we cube it, we get this? A needs to be 2w to the 3rd. No, I'm sorry, 2w to the 2nd. 2 to the 3rd is 8, and then if I multiply w squared by itself 3 times, that gives me w to the 6th. B, what do I cube to give me 125? I need a 5 for my coefficient, and I need a z. And now I'm ready to substitute into my formula. So if I do a plus b, that's 2w squared plus 5z. Okay, and then I've got the trinomial. When I do this, I'm going to use some square brackets because I'll have parentheses inside parentheses. So I'm going to do a squared, so that's going to be 2w squared, and then I have to square that. The formula tells me to subtract a times b, so I'm going to do 2w squared times 5z plus, and then b squared, which is I'm going to square 5z. Be careful that you square both the coefficient and the variable in these problems. A lot of times students forget that they have to square both the 5 and the z. So let's see if we can simplify this. There's not anything that I need to do with the very front binomial. The trinomial will become 4w to the 4th minus, that'll be 10w squared z plus, that's going to be 25z squared. All right, and again, the nice thing about these formulas, like I said before, is as long as you didn't forget to remove a GCF, Once you use your formula, you are done. So it looks like a lot of stuff in here, but we're finished. That's all we have to do. We applied the formula, and we can move on to the next topic. Okay, so a very important skill that you need in this course, or really any math course beyond this, is being able to factor completely. In order to factor completely, that means that you have factored everything that can possibly be factored is factored. As an example, let's look at example 7, part A. We have negative 3x to the third plus 27x. When you're asked to factor completely, the first thing that you need to do is determine if you have a GCF. Is there anything that can come out of all your terms together? If there is, you need to pull the GCF out to the front first. The next thing you're going to look at is the number of terms. The number of terms will help you determine which method that you need to use. This one definitely has a GCF. We notice a common factor on the coefficients of 3. And then each of them have a common variable of x. Also, you'll notice that the first term is negative, and generally we prefer to avoid starting out with a negative. So anytime our first term is negative, we'll go ahead and factor whatever GCF that we're going to factor out, we'll factor the negative of that out. So let's factor out for our GCF negative 3x. If I factor negative 3x out of my first term, I'm left with x squared. And factoring negative 3x out of 27x is going to leave me with negative 9. Can I go any further? Well, x squared minus 9, that's something that we need to be able to recognize as a difference of squares. Again, x squared is a perfect square, 9 is a perfect square. They're being subtracted, so because that's a difference of squares, yes, it can go a step beyond this. Your difference of squares formula, if you recall, is a plus b times a minus b. So in this piece, a, what do I have to square to give me x squared? Well, a is going to be x, and b, since I square 3 and get 9, b is 3. So bring your GCF down. Use your formula. A plus b is x plus 3 times a minus b gives me x minus 3. Okay, now I'll look at what I have left. Could I go any further than this? The answer is no. That's as far as we can take it. So our answer is negative 3x times x plus 3 times x minus 3. In example 7, part B, we're asked to factor 2w to the 4th minus 32. Again, we need to look for a greatest common factor first. Is there anything that comes out of all of my terms? I can see that 2 comes out of both of them. So factor your 2 out. I'm left with w to the 4th minus 16. Can I go any further? Well, w to the 4th minus 16 can be factored further. Hopefully you can. Do you see why? What is special about what I have here? Does 16 look familiar? That's in our perfect squares list. W to the 4th is a perfect square because your exponent is divisible by 2. So we have a difference of squares. Our A is w squared. Our B is 16. Excuse me, our B is 4. So we can bring the 2 down. That leaves w squared plus 4. And this is just using the formula, a plus b, and then a minus b is w squared minus 4. So I got this piece using my difference of squares formula. Look at what's left. W squared plus 4, can I do any more to that? No, I cannot, because yes, these are perfect squares, but these are being added. And if you recall, the sum of squares is prime. That's the one that I told you to play with on your own and see if you can figure out how to get it to factor. By manipulating all those possibilities, you'll see why it does not factor. So the sum of squares is prime. We don't need to do anything to that. W squared minus 4, that's a difference of squares, and that can be factored. This time our A will be W. Our B will be 2, since 2 squared gives me 4. So we'll bring down the GCF, and the other factor that we have. And then we're left with a plus b, this time is w plus 2, times a minus b is w minus 2. And because there is nothing more that can be done here or here, we've got a sum of squares, which is prime here. That's as far as we can take it. So this is completely factored. Okay, and that brings us to the very last problem for section B4. So what do we do this time? We're going to factor, we have to factor completely. We have 4 terms. Well, 4 terms is telling me I need to think about the grouping method. Before I jump into this though, is there a common factor that I can take out of everything? You always need to look for your GCF. If you look at all 4 terms, you will see that the GCF of all of this is 1. So there's no GCF that needs to be pulled out first. So with this being 4 terms, let's do the grouping method. Look at the first 2 terms. These share a common factor of a squared. That leaves me with a plus 1. Over here, this is a subtraction in between, so we're going to whatever comes out, we're going to factor out a negative. So we're going to say minus 4 parentheses, and we're going to factor out negative 4, that leaves a plus 1. So our factors a plus 1 and a plus 1 do match like we need them to. We could pull out the a plus 1. That leaves us with a squared minus 4. Can we go any further? A plus 1, no. A squared minus 4, hopefully now you're seeing that, yes, we can go further with that. That's the difference of squares. That will factor as a plus 2 times a minus 2, just using the difference of squares formula. So we've got a plus 1 times a plus 2 times a minus 2. And that is as far as we can take this one. All right. So you've seen all the examples that you need from this section. You are ready to do the quiz. When you've got 4 questions in the quiz, and you should be able to find an identical twin, except with just different numbers from among the examples that we've done together. So good luck with the quiz, and I will see you in class.